difference between a polyhedron and something that is not a polyhedron. So think back to polygons. What makes something a polygon or not a polygon? Edges, sides, angles.
Side length.
So give me something that is not a polygon. A circle. Okay. So apply that to a polyhedron. Which of these is not a polyhedron?
Sphere.
The sphere. Okay. So this is not a polyhedron. Okay. FYI, this is a sphere or your globe. Okay. What else is not a polyhedron? The cylinder and the cone. All right. So here's your cone. Okay. So this is not a polyhedron, and then this is your cylinder. Okay. And this is not a polyhedron. So if you have any curves, bad. Okay. You need to have your straight edges. Okay. All right, then we're going to talk about, specific types of names, okay, for some things. So like the second one here, this is known as a prism, okay? Prism as in, that's a general term. We're going to use adjectives to describe the prisms like a triangular prism, hexagonal prism, octagonal prism, things like that, okay? So a prism, when we get to it later on, has two bases, okay? Some people might look at this and say it's a cube. Well, it can be a cube if it is regular, as in all the edges are congruent to each other. That makes it a cube. So a cube is a very specific type of prism. So you can't say cube for everything, okay? So a cube is a very specific type. What'd you say? Oh, okay. All right, what is the one in the second? And this one, by the way, is a polyhedron. So it's yes, because it has all straight edges. All right? So what about this one on the second row? Is it a polyhedron?
Yeah.
Yes. Okay. Give me a general name for it.
Period. Pyramid.
How about a pyramid? Pyramid is correct. Okay. We're going to talk about how it only has one base and it all comes up to a point. Okay. All right, this one is a specific type of polyhedron. So it is, we'll call it a dodecahedron. Okay, you do not need to know that. You just need to know that it is a polyhedron because there's no curved sides. Dodeca. What's dodeca? How many? 12. Okay, so it has 12 faces. Okay. And then this is known as an icosahedron because it has 20 faces, okay? And I'll show you an example of that later on. And again, you just need to know that it is a polyhedron, okay? You don't need to know the name for an icosahedron, okay? Icosahedron. All right, big idea that we're going to talk about today, and this applies to Euler's theorem, okay, is being able to name a face, an edge, and a vertex. Okay, so I'm not going to worry about the words of it. You just need to be able to recognize them. So your sides are known as faces. So this is a face. Okay, so if I take the box up here, how many faces does this have?
6. 8. 6. No, 6. 6.
Oh,
All right. We had 3s, we had 8s, and it looks like it's narrowing down to 6. Left and right, top and bottom, front and back.
6.
Okay, 6. If you think about it like a die, okay, if you're playing dice, rolling, okay, there's 6. All right, 6 numbers on it. All right. Edges. Edges are where your faces come together. So this is an edge, this is an edge, this is an edge. Okay, it's where your faces come together. Okay. So make sure you understand what an edge is. Again, all you're going to have to be able to do is count them. So I'm going to give you a polyhedron, and you're going to just have to count them. So you have to recognize what it is. And then a vertex is basically your corners. Okay, so this is a vertex. All right, so let's go back to the box. And how many edges does this have?
8. Wait, 12.
Wait, 9 of that.
12.
I'm looking at
Edges. 12.
Well, it would be the same as on the paper.
12. Whoa.
Okay, it is 12. 1, 2, 3, 4 on the top, 4 more on the bottom, and then 4 going around the sides, okay, so there's 12. How many vertices are there?
8.
8. 4 on the bottom, 4 on the top, okay? So like I said, that's all you're gonna have to be able to do is be able to count them, okay? Questions on what a face, vertice, or edge is? Okay? The top of the second page, they're just talking about polyhedron versus not polyhedron again. You guys did a good job with that. Okay, so now we just need to talk about the idea of a prism versus a pyramid. Okay? A prism is a polyhedron that has 2 bases that are parallel to each other. Okay? So, based upon that idea, there are 2 bases in that. Okay, it's this Toblerone box. Okay, I sacrificed and ate the chocolate, sorry. But I wanted the box. Okay, I know. Okay, so what shape are the bases?
Triangles.
Very good. Triangles. Okay, some people, okay, don't do what I'm going to do here for a second because I'm going to erase it, is a lot of people think, oh, the bottom is always the base. Okay?
That is incorrect.
That is incorrect, because there's not another side that's parallel to that, okay? So instead, it's what Garrett said, and that is, how come it's not,
Technology doesn't.
yeah, I hate when it doesn't work. All right, well, I was trying to erase the red, but, all right, so if anything, here's your bases, okay? Because there's another one that is parallel to it all the way over here. So here are your bases, okay? This is a base, and then this is a base, okay? So when we talk about naming it, okay, we are going to use an adjective, okay, to describe it. And that adjective is the shape of the base. So you would call this what type of prism?
Triangular prism.
Very good. A triangular prism, because the bases are triangles. Okay? All right, on the right, big idea over here is that there is only one base. Okay? So one base. And then to start over here, the non-base sides, okay, so these over here are called lateral faces. What shape are the lateral faces in the pyramid? What shapes are the lateral faces? Triangles. Okay? They're not always going to be equilateral. Sometimes they might just be isosceles. Okay? But big idea is that they are triangles. Okay? What shape are the lateral faces in a prism? So if this is a lateral face, they will always be rectangles. So the lateral faces are always rectangles for a prism. Okay? So a couple of distinguishing ways to figure out the difference between the two. One, prisms have 2 bases that are parallel to each other. Pyramids only have 1 base. Prisms have rectangular lateral faces, whereas pyramids have triangular lateral faces. So if you see triangles, you should be thinking pyramid as opposed to prism. Okay? And then the last thing, just want to talk about it now, we'll talk about it again later, is the height of a prism. Okay? So this is going to be known as the height, is basically the distance between the bases. Okay? So the distance between the bases. Between the bases. That's going to be important, okay? And the reason is, when we go to find surface area, there are actually going to be 2 heights. There's going to be the height of the base, which is this line here, going from the corner of the triangle down, okay? But then there's going to be the height of the prism. So make sure you understand the height of the prism is the difference between the bases, okay? Questions? All right, so if we apply the same idea of naming our figures, okay, just like we did triangular prism, this would be what type of pyramid? It would be a triangular pyramid. So the ones that you see in Egypt, like, the Pyramid of Giza, those are square pyramids because the base is a square, okay? But you can have a pentagonal pyramid, you could have a hexagonal pyramid, so on and so forth, okay? All right. So all we're going to do here is determine whether or not these are polyhedrons. We're going to name it, and then we're going to count the number of faces, vertices, and edges. Okay? So all the things we've talked about. So first of all, is it a polyhedron?
Yes.
All right? If you were to name it, okay, what would you name it?
Rectangular
All right, so it's a rectangular prism. Okay? And the reason again is the bases, okay, are parallel to each other, okay, and they're rectangles, making it a prism, and rectangular because of the bases. Yes. Yes, it's a polyhedron.
So if it's
All right.
we just end there.
If it's no, we would just end on, okay? So then, faces. How many faces does this have?
2. 6.
Oh, yeah.
6?
Yes, sir.
Vertices.
8.
Edges.
12.
Okay, and it's the same as the Kleenex box, so it's pretty much the same thing, all right? All right, so we'll skip over to C real quick. So, Mike, you already asked this question, okay? Is it a polyhedron?
No.
No, so then we don't have to do step 2 and 3, okay?
Can you go back?
We'll go back, all right? So, on B, okay? Is it a polyhedron?
Yes.
Okay, all right? Name it.
Hexagonal pyramid.
Very good.
What is it?
Hexagonal pyramid. All right, and the reason is, remember the adjective is the shape of the base, and notice that the base here is a hexagon, okay, and it's a pyramid. Notice all the lateral faces are triangles. There is only one hexagon, one base, okay? And then step 3, okay, how many faces?
6. Wait, no.
7.
7.
There's the one on the bottom, and then 6 going around on the sides, okay? Vertices,
14.
7, okay?
Come on, Mike.
1, 2, 3, 4, 5, 6, and then 7 at the
I
top,
was being
okay? Edges is not 13, try again.
I said 12. I said
Oh.
14 and then I meant 12.
Oh, it is 12, okay? Again, you can just count them, they're the 6 on the bottom, and then 6 going up to the top, okay? All right? Questions on understanding those 3 pieces? All right, so then, okay, there's actually 2 ways to look at it. It is faces plus vertices minus 2 equals the number of edges. That's the one that you guys came up with. Sometimes you'll see it as faces plus vertices equals edges plus 2. They mean the same exact thing because all they did was add the 2 to the other side, okay? So one or the other. So this, I would think about possibly adding to your formula sheet. I know there's not a spot for it, okay, but you can throw it in there, okay? All right? Just put it somewhere on the sheet, okay?
I will smack you.
All right, so now that we discovered Euler's theorem, try and figure out example number 4. How many faces would it have?
4.
All right, so I like to use the second one, but the first one works as well. If I did f plus the number of vertices 4 is equal to 8 edges plus 2, well, this is 10, 6 plus 10, so f has to equal 6. Okay, and if you did f plus 4 minus 2 equals 8, that works as well. Because you would get 2 and subtract the 2 from 8 and get 6. Okay? All right. we don't focus on the next part a whole lot. Okay, I just want you aware of the terminology. You guys talked about a convex and concave polygon. The idea applies the same to a polyhedron. Reminder that anytime that you can draw a diagonal, a line from one vertex to another outside of the figure, that makes it concave because it's caving in on itself. All right? Convex means that's not happening. And then regular, remember all the edges are congruent. So they're showing an example of regular up here. Okay? So I talked earlier about a cube. A cube is regular because all the faces are regular, all the edges are congruent. Okay? We okay?
Yeah.
All right. So a cross section is like, imagine like a block of cheese. Like if anybody ever gets like the big old Kraft cheese, big old block, or Velveeta block cheese, and then you make slices, or bread. If you were to slice it, what shape would you get? So in this case, if we had a cube and we were to slice the bread this way, what shape is this purple figure right here? I need a two-dimensional name. So something on the back of that cardstock. It's a square, because since we said it was a cube, tick, 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 it's the same distance all the way around. Okay? Over here, if I slice it diagonally though, what would I get?
Oh, it's a pyramid. It's a rectangular pyramid.
It has to be two-dimensional.
Rectangle.
It's just a rectangle. So you're thinking of the whole thing being cut. They just want to know what the shape would be of the base that is cut. Okay? So it's a rectangle.
That makes more sense.
It's not a square
So
because
just the shaded part on there?
just the blue. What's the blue? Okay? So to give you, I have time in class to start it. Maybe you can get it done. Oh, yeah, you guys talked a little bit more than the other classes.
5 minutes.
So, all right, so just a little checklist here. Do you understand the difference between a polyhedron and a non-polyhedron? What makes it not a polyhedron? Circles, okay, or curves, okay? Would you be able to distinguish between a pyramid and a prism?
Yes.
Prism has how many bases? Pyramids have?
One.
Would you be able to name it? All right, so to check out here, what is the name of this shape here?
Square pyramid.
Square pyramid, okay? What is the name of this shape? Triangular prism, very good. On the very back of your purple packet, what's number 7 right here? What shape is this? A pentagonal prism, because there's 2 pentagons that are parallel to each other. Okay? So you got to be able to name them. All right? Last thing, do you understand the idea of faces, vertices, edges, and would you be able to count them? So we're good?
Yeah.
All right.